Hi guys, in today's lecture we'll be considering lattice energy, equation representing the lattice energy. We'll be talking about enthalpy change of atomization, equation representing enthalpy change of atomization, and also we'll be looking at electron affinity, equation representing electron affinity, successive electron affinity. So please, I want you to listen attentively and get the best out of this lecture. Thank you.
So as you can see, these are the lattice structure of ionic compounds. This are what we call giant ionic lattice. When we talk about lattice, is the arrangement of atoms, molecules, or ions in a regular repeating pattern. So these are the word ionic lattice of what ionic compound, which consists of what aggregate of oppositely charged ion. This is the ionic lattice of what sodium chloride, arranged in a regular repeating pattern of the ions, sodium ion and what chloride ion, arranged in a regular repeating pattern, giving us what the ionic lattice. This is the ionic lattice of calcium fluoride, which consists of what calcium ion and what fluoride ion, arranged in a regular repeating pattern. So these are what various different ionic lattice. So these are lattice structure, ionic lattice. Now, so we'll talk about lattice energy. Lattice energy, it is the energy that is released when 1 mole of an ionic solid, an ionic compound is formed from its gaseous ions under standard conditions. So when ions combine to form an ionic solid, there's a huge release of energy. Huge amount of energy is released. That means the reaction is highly an exothermic reaction. And we all know what an exothermic reaction is. And during lattice energy, what happens? It has to do with formation of an ionic compound from its gaseous ions. And enthalpy of formation is exothermic. During formation, heat is released to the surrounding environment. So the energy given out when ions of opposite charges come together to form a crystalline lattice is called the lattice energy. Just as you've seen the lattice structure, ionic lattice from our previous slide. So we'll talk about the energy given out, the energy released when ions of opposite charges come together. When sodium ion, chloride ion, calcium ion, and fluoride, and when they come together to form a crystalline lattice, is called the lattice energy. So in general, lattice energy is the enthalpy change when 1 mole of an ionic solid is formed from its gaseous ion. When 1 mole of an ionic solid, is formed from its gaseous ion, chloride ion, gaseous chloride ion, under standard condition. We'll talk about standard condition. We're talking about a temperature of 298 degrees Celsius, 298 Kelvin or 25 degrees Celsius. We're talking a pressure of 101 kilopascal or 1 atmosphere. If a solution is involved, the concentration must be 1 mole per dm cube. So we'll talk about lattice energy. It is the enthalpy change when 1 mole of an ionic compound, sodium chloride, is formed from its gaseous ions, sodium ion and chloride ion under standard condition. When 1 mole of an ionic solid is formed from its gaseous ion, calcium ion plus fluoride ion, gaseous ion under standard condition. So we'll talk about the lattice energy. So during the formation of an ionic compound, energy is released to the surrounding environment. So the reaction is an exothermic. Huge amount of energy is released. Large amount of energy is released. So that's only about the lattice energy. So this is an equation representing the lattice energy of sodium chloride. The reaction is always an exothermic reaction. You can see large amount of energy is released to the surrounding environment, which is for sodium chloride. The lattice energy of sodium chloride is minus 787 kilojoule per mole. The lattice energy of magnesium chloride is minus 2,526 kilojoule per mole. The negative sign is an indication that the reaction is an exothermic reaction. Please, there are certain things you need to put into consideration. Remember, take note that It is the gaseous ions that combine to form the ionic compound. The gaseous ion. Please take note, the gaseous positive and gaseous negative ion. And the lattice energy is always exothermic. Why? Because the value of the lattice energy is always negative. So, because the definition specified bonding of ions together, not the separation of ions. So, gaseous ions come together to form what? An ionic compound with an ionic what? Ionic bond. Now, the value of the what? Lattice energy shows how stable the ionic compound is and shows how strong the ionic bond is in that ionic compound. And you can see that magnesium chloride as an ionic compound is more stable than what? Sodium chloride, because the lattice energy, the magnesium chloride has what? A large exothermic value of the lattice energy compared to what? Compared to sodium chloride. So magnesium chloride is more exothermic compared to sodium chloride. So magnesium chloride is more stable, have a stronger ionic compound. Stronger ionic compound. The ionic bond is strong. So that is that. So these are equations representing what? The lattice energy. They can give you an ionic compound and they will say write an equation to represent what? The lattice energy of this particular ionic compound. As you can see, it's as simple as what? As ABC. How can we determine the lattice energy? Determination of lattice energy. Now the lattice energy cannot be determined directly, meaning it is impossible to determine the lattice energy of a compound by just a single experiment. So lattice energy is calculated using several experimental values and an energy cycle called a Born-Haber cycle that work using the principles of the Hess's law. So now to do this, we need to introduce two more types of enthalpy change. Then we're going to talk about the enthalpy change of atomization and enthalpy change of electron affinity. We're going to talk about electron affinity and enthalpy change of atomization. So we need to have a comprehensive understanding of the term enthalpy change of atomization and electron affinity. So we need these values so that we can confidently accurately calculate the lattice energy of a particular ionic compound. Now we'll talk about enthalpy change of atomization. What is enthalpy change of atomization? It is the enthalpy change when 1 mole of a gaseous atom is formed from its element under standard condition. When 1 mole of a gaseous atom is formed from its element. When 1 mole of a gaseous atom, like chlorine gas, 1 mole of a gaseous atom is formed from its element under standard condition. 1 mole of a gaseous atom, it must be 1 mole of a gaseous atom is formed from its element under standard condition. This enthalpy change of atomization of sodium, when 1 mole of a gaseous atom is formed from its element under standard condition. Now the enthalpy change of atomization can also be regarded as the enthalpy change of sublimation. If the element is in its solid state, you are converting solid directly to gas. So that is sublimation. So the enthalpy change of atomization can also be regarded as the enthalpy change of sublimation. If the element is in its solid state. So the value of the enthalpy change of atomization are always positive. That means the enthalpy change of atomization is an endothermic process because energy must be supplied to break the bonds holding the atoms in the elements together. So please, I want us to take note of it and be able to represent an equation showing the enthalpy change of atomization of an element as we've written the enthalpy change of atomization of chlorine and the enthalpy atomization of sodium. Now, this is the equation represent the enthalpy change of atomization of lithium when 1 mole of a gaseous atom is formed from its element. And remember, enthalpy change of atomization is always endothermic. It's always positive. The enthalpy change of atomization of chlorine when 1 mole of a gaseous atom is formed from its element, and you can see the value is plus 122 kilojoule per mole. So it's always positive. It's an endothermic process. That means energy is needed to break bonds. Now, let's talk about electron affinity. When we talk about electron affinity, it's just the energy change that occurs when a gaseous non-metal atom accepts an electron. So when a gaseous element forms an ion with more than one negative charge, we must use successive electron affinity, just like the ionization energy of the first ionization energy, second ionization energy, third ionization energy. That's how we have electron affinity, successive electron affinity, first electron affinity, second electron affinity, third electron affinity. Who will talk about electron affinity? So it's the energy that occurs when a gaseous non-metal atom accept one electron. So just like we have successive ionization, we have first electron affinity. Just like we have successive ionization energy, we have first ionization energy, so we have first electron affinity. So first electron affinity is the enthalpy change when 1 mole of electron is added to 1 mole of a gaseous atom to form 1 mole of a gaseous minus 1 ion under what? Under standard condition. For example, this is the first electron affinity of what? Chlorine. When 1 mole of electron is added to 1 mole of a gaseous what? Non-metal atom to form 1 mole of a gaseous minus 1 what? Minus 1 ions under standard condition. When 1 mole of what? Electron, 1 mole of electrons is added to 1 mole of a gaseous atom to form 1 mole of a gaseous minus 1 ion under what? Under standard condition. Now, chlorine as an element have 7 electrons in its atom shell. The valence electron of chlorine is 7, so chlorine needs 1 electron to complete its what? Octet state. So we have first electron affinity of what? Chlorine. When 1 mole of electron is added to 1 mole of a gaseous atom to form 1 mole of a gaseous what? Minus 1 ion. Under what? Under standard what? Under standard condition. Now it depends on the element. An element like oxygen, for example, has 6 electrons in the atom shell. So it needs 2 electrons to complete its what? Octet state. So in oxygen, we can have first electron affinity and second electron affinity. Now the second electron affinity has to do the enthalpy change when 1 mole of electron is added to 1 mole of a gaseous minus 1 ion, added to 1 mole of gaseous minus 1 ion to form 1 mole of a gaseous what? Minus what? 2 ions. Under what? Under standard condition. So the second electron affinity is the enthalpy change. 1 mole of electrons is added to 1 mole of gaseous minus 1 ions to form 1 mole of a gaseous minus 2 ions. Under what? Under standard condition. As you can see, this is an equation representing the first electron affinity of oxygen, and this is what? The second electron affinity of what? Oxygen. In the first electron affinity, when 1 mole of electron is added to 1 mole of a gaseous atom to form 1 mole of a gaseous minus 1 ion under what? Under standard condition. Now from the enthalpy change of electron affinity value, you can see that the second electron affinities are always endothermic, and so are the third electron affinities. The second electron affinity, third electron affinity, they are what? Always endothermic. But first electron affinity is always what? Exothermic. So the second and the third electron affinity are always endothermic. This is because you are adding what? A negatively charged ion to what? An electron. Both of them are negatively charged. So energy is needed to overcome the repulsive force of attraction between the negatively charged ions and the electron. That is why the second and the third electron affinity are always what? Endothermic, because energy is needed to overcome the repulsive forces between them. So the equations represent the first and second electron affinity. You can see that the first electron affinity is negative, it's an exothermic process. Second electron affinity is what? And what? Endothermic what? Endothermic process. It's endothermic. So we'll talk about electron affinity. So the change is from a gaseous atom to gaseous minus 1 ions, and the enthalpy change for the first electron affinity is generally what? Exothermic. So this is an equation representing what? The first electron affinity of chlorine with an exothermic reaction, and this first electron affinity of what? Sulfur, which is what? Exothermic. So the first electron affinity is generally what? Exothermic what? Exothermic. Now, so from what we've just done now, I believe you should be able to what? Answer questions based on what? Describe the lattice energy of what? An ionic compound using what? Using an equation to represent the lattice energy of what? An ionic compound. So I'll be giving you this to do. Write equation describing the lattice energy of magnesium oxide, lattice energy of potassium sulfide, and lattice energy of what? Magnesium nitride. It's as simple as what? ABC. Just go through the slide, listen attentively, pay attention attentively. I believe you should be able to what? Comfortably what? Give an equation representing the lattice energy of each of these ionic compounds accurately. Then the next assignment I'll be giving, the next task I'll be giving to you, you have to write equations including state symbols that represent the enthalpy change of atomization of nitrogen, atomization of calcium, and atomization of what? Iodine. They are as simple as what? A, B, C. So please, I just want you to attempt these questions. I think the last one I'll be giving you is, you're going to tell me, suggest why the second and third electron affinities are always endothermic. The first electron affinity of sulfur is minus 200 kilojoule per mole. The second electron affinity is 640 kilojoule. Calculate a value for the enthalpy change when it comes to electron affinity of what? Sulfur. So it's just a summation of what? The first electron affinity and the second electron affinity, because sulfur has 6 electrons in that atom shell, so it needs 2 electrons to complete its octet state. You are going to have first and second electron affinity. So you have to calculate a value for the enthalpy change. It's just going to be the sum of what? The summation of what? The first electron affinity and second electron affinity. Then the last one is write equation representing what? First electron affinity of bromine, second electron affinity of sulfur, the third electron affinity of what? Nitrogen. So please, I just want you to attempt these questions. They are simple as what? A, B, C. Then our next class, I think we might just go through it, and maybe if you've made 1 or 2 mistakes, you can easily correct your mistakes. And those of you that will get it correctly, fantastic. I'll be so happy for you, and I strongly believe you're going to do it. So they are simple as what? A, B, C. So please, just solve as many questions as possible, attempt this task, and we'll meet in our next class. I'm Mr. Joseph, your chemistry teacher. Please feel free to reach me for any difficulty. I'm always there for you. Subscribe to my YouTube channel. Go to the comment section, comment on the, just make comments, and feel free to reach out to me for any difficulty. I'm always there for you. Once more, I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joe, your chemistry teacher. Thank you.